All right, so today we're talking about the factor theorem. We have two objectives here. One is to use the factor theorem to rewrite an equation, and the second one is to factor a higher power function than like an x squared. So the first one, just a vocab note. So factors of something would be these chunks. So x minus 2 would be a factor of this function. The zeros then are what make those factors 0. So like x equals 2, x equals -4, x equals 5 thirds would all be zeros. But the actual chunk of the function is a factor. So looking at this graph, we want to figure out what are the zeros and how do we know? So if we look at when we cross the x-axis, well, we have at -1, at 1, and at 2. So we can figure out the zeros. We want to figure out, well, then what are the factors? So to get -1, we had to have an x plus 1. To get +1, we had to have an x minus 1. And get +2, you had to have an x minus 2. So there are your factors of the g of x function. So that's what the factor theorem says. It says if c is a 0 of a polynomial, then x minus c has to be a factor, or the other way. So if x minus c is a factor, then c has to be a 0. Okay, so now we want to use this factor theorem to write the equation of a function. So here we have a table. We want to write the cubic function that matches this table, and then it says we can leave it in factored form, so we don't need to FOIL it out and get like a long written out answer. So here we have 3 zeros at -1, 3, and 4. So we know f of x is going to be x plus 1, x minus 3, and x minus 4. At this point, we want to check our answer because we want to get 42 when we plug in 2. So I'm going to plug in 2 and see what you get. So f of 2, we have 2 plus 1, 2 minus 3, 2 minus 4. Multiply that all out and you'll get 6. But if we look back up here, I wanted to get 42, so I'm not getting the right thing. So to think of, well, how could I get 7 to look like 40? Sorry, could you get 6 to look like 42? You could multiply by 7, and that would give you 42. So if I take the function I already have and multiply everything by 7 by putting the 7 out front, then when I plug in 2, I'll get what I want. So that would be the equation matching the table. Okay, so back to the example from before. We had our factors that we got from looking at the zeros. But now we want to figure out how could we actually write the equation. We want to figure out what number would go right here. So to figure that out, we can look at the y-intercept. So we know when x equals 0, y is 1. So we can plug in 0 for this function. And you'll have 0 plus 1, 0 minus 1, 0 minus 2. This will give you 2. So we should be getting 2 right here instead of 1. We want to get 2 when we're 0. So this should be 2 right there too. Because to go from 1 to 2, sorry, I'm saying this backwards. Let me start over. We got 2 right here. But we want 1. So it's giving us this 2, but this is what I want. So go from 2 to 1, you have to divide by 2 on both sides. So we need to multiply by a half right there. Okay, so now we're going to use the factor theorem to write or factor out a higher power function. So if we look here, go back and erase that. We can factor these pretty easily. So this is a quick factoring review. I know we've done some factoring, but you can factor out a 5 out of this and you get 5 with x plus 2. We can factor a 3 out of this one and you get 3x minus 5. Okay, so if we keep going down, We can factor these. We've done some like this. So again, my way of factoring, you multiply these together to get negative 10. And then what multiplies to be negative 10 and adds to be positive 9 is going to be positive 10 and negative 1 all over the 2x from your coefficient. This simplifies to 5 over x. So we get 2x minus 1 times x plus 5. This one, if you rewrite this, this is the same as 2x squared minus 6 squared. So it's the difference of perfect squares. So you'll get 2x plus 1, 2x minus, oh sorry, these should be 6x, 2x plus 6 as your factored form. Okay, so some more review, factoring by grouping. You can do factoring by grouping the first two and the last together. Sometimes you change the order around, but not always. So then I can factor out an x squared from the first chunk to get x plus 1, and a negative 4 from the next chunk to get x plus 1. Take out these parts, and you'll get x squared minus 4 times x plus 1. So again, quick factoring. We're not quite done yet. This is the difference of perfect squares. You get x plus 2, x minus 2, x plus 1. And you're factored. Quick review of factoring. Now we're going to do it with other things. So today we're going to know how to factor this one. So it's x cubed plus x squared minus 10x plus 8. Here you could try factoring by grouping, but it's never going to work. So factoring by grouping is kind of a like, hope it works, try it, see, but there's no combination here where you can get them to factor out the same way. So to do something like this, we need to figure out what one of the zeros is. So we're going to do this one. We know from the given information right here that x equaling negative 4 is at 0. So this means x plus 4 is a factor. So I'm going to write this out and put negative 4 right here. And then I'm going to do synthetic division, so I'll put all the coefficients down. We have 1, 1, negative 10, and 8. You could use long division if you like it better. That's just fine. So negative 4, negative 3, positive 12, positive 2, negative 8, and 0. And then a way to check this, make sure you get 0 as your remainder. Otherwise, this isn't a 0. It wouldn't divide in nicely. So it's a way to check your work. If we rewrite this, we want to start with the factor we know. We know we have x plus 4. And then from our answer here, we have x squared minus 3x plus 2. And now we can factor this chunk. That's something we know how to factor. So we still have the x plus 4. This would factor to x minus 2 and x minus 1. And there is your factored form. All right, so another one. Try this one, pause the video, and then we'll talk about it together. So same idea, I'm going to start with 2, and this means x minus 2 is a factor. So we have 2, 7, negative 17, and negative 10. Drop the 2 down, you get 4, and then 11, 22, 5, 10. It works out, we get 0. We write this out, start with the factor you know. We have x minus 2. Write out your new answer like this. And now we can factor this 2x squared plus 11x plus 5. We'll get x minus 2, 2x plus 1, and x plus 5. And that one's done. All right, so this one's a little different. It's up to the 4th now. And then it gives us 2 factors. So we're going to do this process twice. So it's not anything different, it's just a little bit longer. So I'm going to start with 1. It doesn't really matter which one you start with. And we can do 1, 3, 1, negative 3, negative 2. Drop the 1 down, multiply. Oh, that's a positive 2. And we get 2, 0, and it works. So if we rewrite this, we have our 1 factor. This would be x minus 1 from right there. X to the 3rd plus 4x squared plus 5x plus 2. And now we want to keep going. So I can now do this chunk using this second factor. So we can do -1, and then these coefficients. So 1, 4, 5, 2. Drop the 1 down, you get -1, 3, -3, +2, -2, 0, and that one worked. So now we have our x minus 1 from before up here, and then we have our x plus 1 from right here, and then we have x squared plus 3x plus 2, and then we can factor this last chunk. We'll give x minus 1, x plus 1, and we get x plus 2 and x plus 1 here. And then these two you can combine, so that's your homework, but we'd get x plus 1 squared from both of these, x minus 1, x plus 2, and that would be your final answer. And then your homework is a 2.4.2 worksheet.